This will be for the con exercise, estimating limits from tables. Okay, it says the function f is defined over the real numbers. This table gives a few values of f. Okay, so top is the x values, and the bottom row, f of x, are the y values. What is the reasonable estimate for the limit as x approaches 0 of f of x? All right, the thing you want to remember here, and I should say f of x must approach the same number for both sides. All right, otherwise it does not exist. So they are asking us the estimate for the limit as x approaches 0 of f of x. So first let's look at the x's. You can see they are coming from the negative side and getting closer and closer to 0. And also they are coming from the positive side and getting closer and closer to 0. So 0 would be right here. All right. And we want to look at the f of x row and see what the number is approaching. Now from this side here, we can see the number is getting smaller and smaller for f of x. And from this side here, the number is getting greater and greater. Okay, so if this kept going smaller and smaller, it would go down to like -10 and so on and so on. And if this kept going, this would go, I don't know, up to like -2 or 0 or whatever. But right here, the number does not appear to be converging onto anything. Okay, this side's getting smaller and smaller, and this side is getting greater and greater. So they're not going to meet anywhere. There's no meeting point. They're not approaching the same number from both sides. So that's going to be a DNE. Does not exist. Answer E. All right, this time they gave us a table in vertical form. Still the same thing. And what's a reasonable estimate for the limit as x approaches 3? All right, so let's look at the table here. Here is the x column. All right, this right here. So we can see right here, it's getting closer and closer to 3. This is from the positive side. And right here, it's getting closer and closer to 3 from the negative side. The value of 3 would be right in here. Okay, in between these two. So we want to look at the f of x and see what it is approaching. Okay, from here, I can see this is 962, 985, 999. It's getting closer and closer to 10. And from this side, 962, 985, 999, same thing. It's approaching 10 from both sides. So that's it. The limit for x, the limit of f of x as x approaches 3 is 10. All right, here's the table, x values and the g of x values. These are the y coordinates. And they want the estimate limit as x approaches 5. All right, let's take a look. So let's see. This is coming from the negative side and getting closer and closer to 5. This is from the positive side, getting closer and closer to 5. Okay, and they actually have the value at 5. Now, this is a tough one. But if you look from this side, this number is getting greater and greater. And from this side, this number is getting smaller and smaller. So you know what? I don't think the value at 5 really even matters. I'm pretty sure we can just ignore this because I don't think that's correct. I could be mistaken, but these numbers are getting closer and closer to 368, and so are these. So I'm going to go with 3.68 and not 6.37. Let's see what happens. Okay, I'm going with 3.68, And that is because it doesn't matter what the value is at 5, okay? If you evaluate this as a g function, if you evaluate g of 5, that does not necessarily equal the limit of g of x as x approaches 5, okay? We're not looking to evaluate it at 5. We want to see what the number approaches. So I think, you know what? I might even change my answer. If you see these numbers, they're getting greater and greater. And let me see. These numbers are getting smaller and smaller. So one of the answers was 4, but we can't say 4. We can't say 4 because this side is not approaching 4. I think 3.68 is the answer, okay? Because I don't want the value at g of 5. I want to see what it approaches. So I'm going with 3.68. Could be wrong, though. Let's see what happens. Okay, good. I got it correct. Let's see what they say. Okay, then in their answer, they didn't say anything different than I did. The g of x value seemed to approach 3.68. All right, so that's it. So lessons learned here, don't just evaluate the function at g of 5 and think that's the answer. You want to see what it approaches, not what it actually is. Okay, here we have a few values for the function h. What is the estimate for the limit as x approaches negative 10 of h of x? All right, so our x values here, they're supposed to approach negative 10 from both sides. Okay, so negative 10 would be right in there. And we want to see the f of x value. All right, now this side, the number is getting greater and greater. And this side here, the number is also getting greater and greater. So I think they're never going to meet. Okay, if both sides are just getting greater and greater, that's no good. I don't think they're ever going to meet because this side here is headed to, let's say, if we kept going, this would head to like negative 8.5. And this side here, if it kept going, it would go to negative 7.5. I don't think they're ever going to converge or meet somewhere. So I'm going to guess does not exist. All right, it does not exist because they did not converge on any number. Okay, if you try any of these numbers and look at the table, you'll see that the number for h of x does not converge on any of these numbers. It has to converge on the same number from both sides. So that does not exist.